So, my name's Vallely. I'm currently a software engineer at Apex Fintech Solutions, and I have been here for 2.5 years. But today, I'm going to talk to you about my latest problem. So, I skipped a slide. Okay, so, what's the problem? Well, what was the problem that developers were finding integrating with our 130 APIs? Then, how do we solve this? How do we solve this using some generated code, a little bit of AI, and putting it all together in an automated pipeline? What did it look like for developers before? And now, what does it look like them after we came along? And finally, what's next? So, who cares? And why am I standing here today? Well, two people care. Apex Fintech Solutions care because we created this new platform called Ascend. Ascend's made up of 130 APIs, but each one of these APIs took about 100 to 1,000 lines of code to integrate. This was something they struggled to market. It wasn't very appealing to our potential clients, and finally, our client developers. What were they thinking? When they signed with us, and then they were like, here, integrate with a product, but spend your days writing thousands of lines of repetitive code. So, what actually is Apex? Apex is the back end of the modern financial services. It's what fintech and financial companies use to create these empowering products. It removes barriers and makes everybody an investor. So think of them as your tech and infrastructure partner behind the modern back-end scene. They create APIs that help things like execute trades, manage brokerage accounts, withdraw money, and analyze data. So if anybody in this room has ever made a trade using a trading app or open an account, you've probably interacted with one of our APIs. Some of our global clients include eToro, Elvest, Webull, Crypto.com, and so many more, but I don't know how many I'm allowed to say. So, 130 APIs, what do they do? So, as I mentioned before, think of trading, managing accounts, withdrawing money, funding accounts. This is what they do. But each API takes 100 to 1,000 lines of code to integrate. So, how powerful are these actual APIs? Well, 20 million brokerage accounts have been opened using them in 171 different countries. They're a total of managing $164 billion, and last year alone, they helped submit 663 million trades. So, before I talk about how we redefine this and change the game for our developers, let's really focus in on what the problem was before. It was time consuming. When developers signed with us, it was taking them months to open their first account with us, and integrating was taking far too long. It was tedious for developers. Imagine getting really excited to work on this innovative project and then find your days writing code for serialization and deserializing data. And finally, with all this repetitive code, errors came along. And based on my previous slide, our APIs are responsible for handling a lot of people's monies and executing trades. So errors simply just weren't an option. So developers weren't happy. They were spending too much time, too much effort, and fighting too much unnecessary risks. These developers are the key innovators. They're the people feeding back to their company and saying, hey, what technologies we should use that are going to make us the most money and ensure the most scalability. So this is where we needed to change the game. We needed to transform our API integration experience. So this is where I came in. I joined a team called Client Developer Experience. This team focused on putting developers first, and this is where we started our first journey of creating our first set of SDKs. So what even is an SDK? Well, SDK is a software development kit. It bundles resources together in a powerful toolkit, such as pre-built libraries, tools, coding snippets, and documentation. This means that it takes something that was a complex system into something more developer-friendly. So why an SDK? Well, it simplifies development. And how does it do that? Well, it simplifies development because there's these ready-made, reusable components. This means developers don't have to start from scratch. Then, It improves developer experience. How does it do this? Well, SDKs come with stuff like documentation and coding snippets. This means it's an overall smoother developer internal. Enhanced security. Security, always a major factor. But with an SDK, it standardizes and simplifies things, such as auth management, API encryption, and monitors API usage. So one less things developers will have to worry about. And finally, it reduces costs. Time is money, so the faster developers get the market, the more money developers can make. So how did we actually do this? How did we build it? Well, the first thing we need to do is we need to talk about our requirements. So we wanted to make something that was scalable, reliable, and most importantly, future-proof and not future frustrating. So the first thing we had to do was make it maintainable. Why did it have to be maintainable? Well, our APIs are heavily regulated by a company called FINRA. This means they're constantly needing updated to fit with the latest requirements, and we're also adding value-added features. We needed to make it a way that our SDKs were always up to date and backwards compatible, so our developers never faced any disruption. It had to be automated, but automated here takes an approach of how we wanted to build this SDK. We wanted to build it based on our OpenAPI specs. We wanted to generate the code automatically. I didn't want to be responsible for maintaining thousands of lines of code of SDKs and having to write it. And we also wanted to remove human error as a factor. So, documentation. Misinterpreting API documentation is a common pain point for developers. So we wanted, and for us, it was hard to maintain. So we wanted a way to have our SDKs have maintainable, clear documentation so developers were never lost. So, and we wanted to ensure broad adoption. So we wanted to build it in 4 different languages. Can anybody guess what languages that we would have picked? Yes. Python, yes. Java, yeah. And Node, yes. So TypeScript. So yeah, we went for Java, TypeScript, Python, and Golang. So how did we do this? Well, we partnered with a company called Speakeasy. Speakeasy made this all possible. So what does Speakeasy do? Speakeasy gave us the ability to generate these type-safe SDKs based on our OpenAPI spec. This meant 2 things. 1, our APIs were always up to date with the latest API spec, and 2, it was consistent across the multiple different programming languages. Speakeasy also gave us type-safe SDK. So what does this mean? It meant that when developers were integrating with our SDKs, they were getting real-time validation and protection from common code and errors. And then Speakeasy really understood our API design as they were built off the OpenAPI spec. This meant it understood the full capabilities of our APIs. This meant there was no hidden features or no unpredictable behavior. With Speakeasy handling the heavy lifting, so generating the code, it meant that our team was free to focus on scalability. So this meant that we were able to create these SDKs in these 4 different programming languages. So we know, now we've got the point. We've got the tool that's going to generate this code, but we needed this one single source of truth, this one API spec that defines all the 130 APIs in detail to generate the code. So what was the problem before? Well, each team, like the account service, was responsible for handling and managing their own API documentation. This was inconsistent and inefficient because, let's be real here, how many people have forgotten to update documentation in time? I have, definitely. So how do we fix this? Well, we generated an OpenAPI spec for each team based on their proto file. And then we merged each one together to create one single source of truth. This came with its challenges. So, despite being over 176 words in the English Oxford Dictionary, teams still somehow managed to name the things the same despite meaning completely different things. So this meant we had to go back and forth to teams and gently encourage them to change their name. And when that failed, we had to get out and start doing some bash scripting to fix this problem. So take a look. Here's an OpenAPI spec. So what is an OpenAPI spec? What is an OpenAPI spec? Well, it's the blueprint. It's a blueprint of your API. So it handles stuff like the response body, the request body, all your error handlings, and a detail of what your API does. So here at Apex, all our APIs are written using gRPC. This is better for performance, but that meant to be able to use an OpenAPI spec, we had to have another tool that converted from proto files into our OpenAPI spec. This gives us the ability to bridge the gap between REST APIs and gRPC without sacrificing performance. So we've got the generation of code via Speakeasy. This is where Speakeasy came to play. So what did Speakeasy really allow us to do? It generated code. So it generated all the objects, the models, and the classes that developers needed. This meant developers didn't have to write any repetitive code. Type safety. It provided type safety for strongly typed languages. What does this mean? It meant that we can improve developer confidence. Helper function and classes. This meant when you were integrating with our APIs, it was always intuitive and efficient. And finally, documentation. This meant developers understood exactly what they had to do to integrate with our APIs. They knew what fields was required, what error handling would come back. It was all handled for them. So using generation by code via Speakeasy wasn't just about speed. It was about consistency. This meant that every single API or every single SDK generated by Speakeasy was the same, no matter what programming language you were using. It was always consistent and reliable. So we put this together in a pipeline. So what happened? How do we bring all these tools together? So we use a pipeline in GitHub Actions. The first thing that happened when a team updated their proto file, it kicked off our first pipeline. This regenerated all the OpenAPI specs and then merged them into our one single source of truth. Once these were merged together in our one single source of truth, we were able to generate our SDKs in our 4 different languages: TypeScript, Java, Python, and Go. Once they were generated, we linted them. Linters definitely work quite well, but when you're generating 2,000 files, they break a little bit. And so does GitHub when you try to merge them into a source file. Don't print up 2,000 files PRs. Your DevX team will definitely come after you. And then once our code was generated, we kicked off a series of automated tests. And then when our series of automated tests passed, we were able to publish these. So let's talk about developers' favorite thing, testing. So we tested using mock servers. We tested if we were the client ourselves. So what were the problems with this? Well, scale. There was 130 APIs written across multiple different teams. I've never tested these APIs before, so I had to go back and forth with different teams across different time zones and be like, hi, what permissions do I do and how do I actually call this API? Ownership. Who was responsible for testing? Should the different teams test this SDK or should I test the SDK? Language-specific bugs. So things work perfectly in Python but could break everything in Go. And to handle this, we created this automated pipeline, these series of automated tests that kicked off every time our SDK was regenerated. To improve this further, we're actually starting to look into this new program or this new file called Aritzio. Think of Aritzio as your OpenAPI spec, but for testing. You're able to define what tests we want to do, the end-to-end tests, and they're actually going to be able to generate end-to-end tests in all different programming languages. This will ensure our SDKs continue to be robust for our clients. So now we're going to publish. So how did we publish? We published using a series of GitHub actions to npm Maven, Go, and PyPy. I thought publishing was the easy bit. The final, we did it, we generated the code, and the final piece of the puzzle. But our legal team and our InfoSec team weren't very happy with us going open source. So we had to convince them that our APIs were going to be secure and the libraries would be fun. Because, as you remember, I talked at the start, our APIs are responsible for handling a lot of people's money. So here's a tour of our library. Hopefully you can hear me. If not, I will continue speaking. Here's a look at our public Go SDK. So this is the start of the repo, and this is where our weekly file is, and you can start to see some of the level of code that we've generated here for the Go SDK. And we can see all the different components in Go that developers would have had to write before, but now it's all generated by Speakeasy. You can here it really shows the sheer number of components that are required to interact with the APIs before, but now this is no longer required. So here is an example of a class that's generated, the legal natural person. All the code is generated with comments, so if developers want to look for it, it's easier for them to understand. Here you can see all the different methods, functions, and types that are generated via our Go SDK. You can see this class in particular is 1500 lines, so that's 1500 lines developers, or our team doesn't have to write. This is a look at the documentation that we provide. This documentation is generated with the help of Speakeasy. It's based off our OpenAPI specs. In Team's proto files, they label and the documentation and label what each field does. This means Speakeasy is able to fill the gaps using AI and provide detail on what the documentation does. All the documentation is reviewed by our tech content team, and they add some diagrams and more information, ensuring it is correct. Next is our API guides. These are also generated by Speakeasy and via the OpenAPI spec. So they give a detail about which field you need and example what the field actually does. There's also sample data here for it, and then you're able to see the error responses here as well, and all the different APIs are all listed. You can also have a go at trying the API here. You will just need your auth token and API key. So yeah, that was our tour. So you can actually go view this library at AFS Public Ascend Go on GitHub. You can see here that you can see the amount of code that we were able to generate and give to our developers. And we were also able to see our documentation, the detailed documentation that we were able to generate automatically every time the API was updated. As you can see, it's posted on README, and that we actually also have automated pipelines that publish directly to README. So let's take a look at the before and the after. So 300,000 lines in Java, 80,000 lines in Python, and 110,000 lines in TypeScript. So what do these numbers actually mean? These numbers are the amount of code developers had to write before, and the number of lines that we were able to generate automatically using Speakeasy. Speakeasy allowed us to redefine what was possible. We took what would be months of developers' effort and automated and generated. The best thing about it was developers no needed to have to write this tedious, repetitive boilerplate code, and neither did I. Speakeasy showed us that it was possible to break down, not just remove barriers, but break them down altogether. Developers were now able to spend time focusing on their core business logic instead of writing repetitive code and getting an API up and running. And for our team, it meant that we could focus on providing more value for our developers and continue creating SDKs in different languages. So this is some code that developers had to write before. This focuses on their serialization data. continue, this is more code. They had the right to integrate this one legal natural person's API. So this is for serialization, serialization of the data, and some of the retry and error handling logic. Some more code relating to the error handling and the serialization. And finally, this is the request body that they had to serialize, never mind the response body. And this is what they have to do now. It's simply 4 lines of code instead of the hundreds that I showed before. What is actually happening here? Well, the first thing is there's no need for serialization and deserializing data. Developers no longer have to validate response schemas. Number 2 is that authentication is handled. There's transparent token management, meaning developers don't have to worry about auth when sending each request. And finally, the error handling and retry logic is handled here. This means developers don't need to reinvent the wheel when coming to validating requests. So here's a quote from our client. This shows how much we were able to accelerate clients' time to market when we put developers first and automated their success. These developers were happier. They no longer had to write these boilerplate lines of code, overall being more successful. It meant they could focus on their core business logic, never mind having to worry about getting an API up and running. So what's next? Well, we want to add more features. We want to make our SDKs even better. So maybe that's adding another programming language, adding stuff like pagination to our SDKs, handling stuff like React hooks. And as I mentioned before, fixing and handling our end-to-end testing better. And then what's next for you? What can you do? Well, if you want to go open source and generate SDKs, you have to start with a clear, defined API spec. This means that your APIs, we can base your SDKs off. So this is, you use OpenAPI if you develop using REST, or you would use proto files if you develop using that. Finally, automate the SDK process. Do you see what we did? Why would you bother writing these lines of code yourself? So we used a tool, a company called Speakeasy. You can use your own, but I'm a bit biased, but I would recommend using Speakeasy. And then finally, publish, but make sure you test it very thoroughly first. And once you publish, you're going to get loads of feedback from developers. So always iterate and improve. And that is me. So thank you very much, everybody.
Thank you.
Does anybody have any questions?
Stole my line.
Oh, sorry.
Oh, sorry, right behind me. Yep.
Hi, that was brilliant. Thank you so much, Lauren. I have a question. You mentioned that you had to do a lot of work to convince your legal and InfoSec teams that it was safe to do this open source. What did that involve?
It was just making sure that we had the right licenses to make sure we were able to do it. And then also making sure that all our APIs could be, you needed to actually integrate with them, and a good API key and a service account.
Great. Any others? No. Thank you very much. Oh, sorry, there is. Oh, God, no, I'm being terrible. Sorry. Oh, I should be better experienced at this job by now.
Thanks, Lauren. That was a really, really good talk. What was your favourite part of the whole process?
I think the favourite part was when we actually got everything together and got the OpenAPI spec up to date. And then when we finally ran that first command by Speakeasy and we were able to generate like 2,000 classes and all this lines of code and actually being able to see this. And when we got our our pipeline working, yeah, no, it was just really cool. It was something that we were able to do. And be like, wow, imagine having to write all this, and we didn't. Yeah, so.
Cool. Oh, there is more.
With the 4 languages you're now publishing in your SDK, have you any issues with keeping them in sync if one language breaks, or
So that's the good thing about using Speakeasy. So it meant that all our SDKs are all sort of consistent across the across the 4 languages based on the OpenAPI spec. So that's why we have our automated testing. So once they kick off, yes, there's some things back and forth, but surprisingly, we have a lot less problems than we thought we would have had.
Thank you.
Okay, cool. Thank you again. I certainly took away how flipping verbose Java is compared to the others. So once again, big round of applause. Thanks, folks.